Diamond is not here. Marta, Andre is not here. Christina is not here? Where is she? Sydney.
I just done 2 days.
Oh, Christina. Where were you, honey? Hey, welcome back. Take one of these. Oh. Christina, come up here. Take one of these.
I thought you said you were
I just told you I was gonna be up in here.
I forgot.
No, I have one, but thank you.
You gotta write on there.
I don't need one, but I'm gonna lay it on my desk.
What month is that?
The what?
My test.
Wait, let me take care of something. All right, please guys, start working on these sheets. They should be easy. I explained this to you yesterday. Jamal, are you coming for the test? Okay, come here, take it. Jamal, come here, let me show you something. Look what diamond is that? Way hard.
What's that, a D?
She's smart. You are too. You're lazy. There you are. Ah. Oh, there you are.
Look at it do like that.
Okay, let's go over the first question. Write a fraction with a numerator of 12 and denominator of 13. Which one is the numerator? Which one is the denominator? What do I mean? The numerator is how much? And the denominator is? And if you forgot, guys, remember, denominator starts with what letter? That's down. D. Denominator is down. So 13 is down because it's the denominator, and the numerator is 12. Okay? Now, let's go to the second one. Circle the fractions that are in simplest form. 15 and 30. Do they have anything in common?
Yeah.
Yes.
Yes, both of them are divisible by what? 5. Let's go to this one. 5 and 18. Anything in common? So this is simplest form or not simplest form? Now, let's go to the next. 17 over 42. Yes or no? Can 17 go over to 42? 17 is a prime number, but if you multiply it by 3, it's not going to be 42, right? It's going to be not 42. Then what about 22 over 33? Is this in the simplest form, or they can be simplified more? Both of them are divisible by 11, so this is not in simplest form. So basically, these are the ones that are in simplest form. All right, let's go next. What do I mean a rate? Yesterday, we talked about a rate. A rate is a ratio that compares quantities measured in different units. So if I say 23 miles over 1 gallon, miles and gallons, are these the same units or different units? Different. So this is a rate. $1.32 over 8 ounces. Are these dollars and ounces? Those are different units. And also the third number, 302 words in 5 minutes. Minutes and words, they are different units. That's why we call them what? They have different units. We call them, what do we call these fractions? rates. We call them rates. Come on, guys, focus. Wake up. Okay? Now, I want you to do this. Write a rate for each situation. Chandler bicycles 20 miles per hour. How do I write this as a rate? Every time when we talk about ratios, we talk about rates, what do we keep in mind? What numbers are we dealing with? What kinds of numbers? Are these whole numbers or fractions? Fractions, something over something, that's a fraction. A ratio, we're comparing something to something, that's a fraction. Rate, a ratio with different units, that's a fraction. Okay? So if I go to this guy here, and he bicycles 20 miles per hour, I can write it here. I can abbreviate those words, miles and hours. Okay? Or I can write them in words, doesn't matter. Okay? Now, Anne makes 80 bagels every 3 days. How do I write this as a rate? What do I do? Bagels over, so I do 80 bagels over how many days? Okay. Was this hard so far? So this is just a review to what we learned yesterday. The definition of rate and ratios and now, so far you have read 35 pages out of a 50-page assignment. Explain why the ratio 35 pages out of 50 pages is not a rate. Why do you think this is not a rate?
Natalie. Sorry, go ahead.
Let's go, come on. Amanda, who's more? Come on. Back. Then,
It's 30 pages out of 50 pages, so it's not two different things we're comparing.
good. They are not different units. We're talking pages to pages. So is this a rate?
No.
No, this is not a rate because you can say they have the same unit. Which is what? We're talking about pages. Pages up and pages down. That's not a rate because they have the same unit. Okay? Okay.
Can we move on to the next page?
Yes, please. Yeah. Now, guys, do this. We did this yesterday. Quickly. This should be easy. Jamie, did you finish it? Go sit down. Behind shake. one shape. All right, which one is the cheapest, guys?
C.
C, because I know if I divide the first one, 25, divided by 2, that's $12 per shirt. The second one is $11.25 per shirt. And the last one is $10 per shirt. So which one is the cheapest? So store C has the best deal. Any question? All right. Now I want you to do this, guys. We did this kind of like it yesterday. Suresh Sharan ran 10 kilometers in 2.5 hours. Jason ran 7.5 kilometers in 2 hours. Olga ran 9.5 kilometers in 2.25 hours. Who had the fastest average speed? So the same thing, what do we need to find? Just like what we did before, we found the unit rate. We found how much we pay per shirt, right? For one shirt, that's the unit rate. The same thing here. We need to find which one is the fastest. Which one runs more distance per hour? Okay, then we can say this is the fastest, right? So what do we put for the first one, Sarasha? How do I find her speed? What do I do? 10 kilometers divided by 2.5 hours. And how much is that? 4 kilometers per hour. Now find that speed for the other two people and see which one is the fastest. If you have these orange sheets done, please take them off.
You gotta do number 10.
All right, so who was the fastest?
Oh, the last one. How do you say it?
Olga.
Olga.
I did this thing.
Did you pick the wrong one?
Yes.
Okay. Oh, you picked those. Just tell me case you say so I know.
What did Jason beat now?
Let's see, Jason's run 7.5 kilometers in 2 hours. So in 1 hour, he runs how much? He runs 4.1? No,
3.7.
3.75. That's kilometer in 1 hour. And this is Jason, and Olga is 9.5 over 2.25, which is 4.2, repeating, right?
Yes.
So it's about 4.2. So which one is more? 4.2, 3.75, or 4?
No one less though.
Let's compare. When we compare, let's list them up and down. So this is 4. This is the one we like 4.
I know, like,
4.2. and 3.75. And we compare from left to right. Which one is bigger, 4 or 3?
Look at this fastest. That means that it should be the smallest.
No, we're talking about the kilometers per hour.
Oh!
How many kilometers per hour? So she runs more kilometers. So this is the fastest, right?
Yeah.
So when we compare 4, 4, 3, so it's either this one and this one, then go on the second number, 0 and 2. So basically this is the biggest number, right? Now go to the next one. Okay, Washington had an area of 25.4 miles squared and a population of 74,547 during 1 year. California had an area of 113.1 miles squared and a population of 295,536 during the same year. Which city had a greater number of people per square mile? Okay, how do we do this? What are we comparing? What to what? Are we comparing population to miles squared or miles squared to population? Look at the question. Which one should be up? Which one should be down? We go in order. People per square mile. Which one is up? People or mile? People. Okay. We see the people. How much population or how many people on that specific mile square? So let's do Washington first. So we have how many people? We have 74,547 people over how many square miles? Okay. Now, if we divide this, how many people is that? Now, can we have half of a person? What do we need to do with our answer?
Round it.
We need to round. Good. We need to round. So how much is that?
2,645. 2,935.
Over what? Miles squared. Just 1 mile squared, there are 2,935 people. That's where? That's Washington. Now let's do California with the same process. Anja, are you working? Oh. Classmates, is there any other calculator? Can you please check in the box? Thank you. Did you get your haircut? I love it. All right. Now, how many people in square mile?
261.
Let's see. So we're going to divide how many people we have. No, not this one. Where is it?
295.
Oh, yeah. 295,536 people divided by, what's that, square miles? 11. 113.1 miles squared. Those are people. All right. And the answer is how much?
261.
261?
3.
3? Is it 39?
Just
3? Is it a whole number?
yeah, with like extra numbers.
It's a whole number? Oh, 0. Oh, yeah. You're right. So, people. Miles squared. Now, which one has more population? Washington or California? That's 2,900. So Washington has more people. Okay? Are you finished, mister? Now go back to your class. What do you? Oh, I signed it.
Do we move on to the next thing?
Yes, please. Okay. Yeah. All right. Please do the next question. We did this yesterday, guys. We did it in class. Who got the answer for the first one? Miles, you got it? Anybody else? Do you know how to do it though? Yes, Danelli, or no? Yes or no? Okay. Thank you for your answer. All right, let's go back here. Now I know I want to convert 330 minutes into hours, okay? So I need a conversion factor in order to do this. Now, how many hours, or sorry, how many minutes in 1 hour? I know 1 hour is equal to 60 minutes, right? This is my conversion factor. Now, let's go to my original number, which is 330 minutes. Put it over 1. Multiply by the conversion factor. Now, if I do this, where do I put the minutes? Up or down?
Up, down.
Up or down? Down. Because minutes, 1 up, 1 down, they cancel out. So I put 1 hour up and 60 minutes down. See plus 6?
Yeah.
Now, minutes and minutes, they cancel out. So I'm going to end up with hours. That's what I want. Okay? Now, I have 2 fractions multiplied, so I multiply tops and I multiply bottoms. 330 times 1 is 330 over 1 times 60 is 60. If we divide, that's 5.5 hours. Okay? Now, 15 kilograms into grams. I know 1 kilogram is equal to 1,000 grams. Okay? Now you do it. All right, now pay attention, please. So my original number is 15 kilograms, right? So I'm going to start with the original. 15 kilograms over 1. And I'm going to multiply it by my fraction, my conversion factor. Now, where do I put the kilogram? What do you think? Up or down?
Down.
Down. Because if I put it up, I can't cancel them out. So I'm going to put this 1 kilogram down. And what do I put up? 1,000 grams. Now, kilogram and kilogram, they cancel out. 15 times 1,000, that's 15,000 grams. See, I'm changing into grams, so my answer has to be in grams. Okay? Now, the other one, see who can do it. You're changing 5 feet and 3 inches into inches. First of all, what's my conversion factor? How many inches in a foot?
12.
Okay, start with this.
But if you already did it.
No, we didn't do that.
No, I already did. I did. I mean.
What did you get? Excellent. Good job.
Should we move on to the next one? The three?
Yes. That was confusing, guys. All right. Now, there's a trick on this question because you have to convert 5 feet and 3 inches to inches. Do I need to worry about these 3 inches or they already converted? What do you think? 3, I don't need to change it because it's 3 inches and I wanted them in inches. So I need to just change the 5 feet, okay? I know 1 foot is equal to 12 inches, okay? This is my conversion factor. So I'm going to do 5 feet over 1. I'm going to multiply my conversion factor, okay? So where do I put the foot, up or down? What do you think, Renard? How do I cancel this foot out? Good. So I'm going to put 1 foot down, then I put 12 inch up. Now, foot and foot, they cancel out. 5 times 12 is how much? That's 60 inches. Now, with 60 inches, how many more inches do I have? Look at the question, 5 feet, 3 inches. So how many more inches? 3. So that's 60 plus 3, that's 63 inches. Okay? So 63 inches, I just changed 5 foot or 5 feet and 3 inches into just inches. Okay? Now, please do the next one. You have the building, it's 1,450 feet. How many meters tall is the building? And you have the conversion factor. 1 meter is about 3.28 feet. Savannah, did you finish? What was the answer? You agree with her, Donovan? Good. How many of you got this answer?
What answer?
44 something?
44 something. Yeah. I think it was,
All right. Let's do it
40
here.
No, 47, 5, 6.
Okay, I don't know. Let's try it. So I'm going to start with my original number, which is 1,450 feet over 1. And I'm going to multiply it by my conversion factor. Keep in mind, feet should be down because one of them, the first one is up, so they can be canceled out. So 1 meter up and 3.28 feet down. Now, feet and feet, what happens? They cancel out. That's what I want. Now, the answer is, I'm going to multiply across 1,450 meters. That's what I want, divided by 3.28. I don't know what the answer is, though. It's 4 point something or 44 point
Oh,
something.
so we're dividing them all.
Yeah, because see, the feet went up,
Oh,
went down.
it's bigger than meters.
It's not about bigger. Don't do this because sometimes you get confused. Just do it the way I did.
I'm just saying, but like the meters are smaller than like
No, the meter is, this is a meter stick. We have one. This is a meter stick, okay? When we talk about feet, this is 1 foot. So which one is more, meter or feet? A foot or meter? Meter is bigger. You know, I didn't learn this, the feet and the inches and the yards in my country because we don't do this system. We do the metric system. So I'm very familiar with the
threshold.
yeah.
It's actually probably more useful to actually use the metric system.
No, it's confusing because the entire world they use the standard system, like which is the one we're using, but just the United States they use that.
I know.
Foot and inches, and I don't know why.
My stepdad was an astrophysicist, so yeah. Well, he worked in the he worked in the astrophysics department. He's more of a theoretical physicist, but.
All right, guys,
Yeah.
please flip to the next page. And while you're doing this, I'm going to give you a table to help you out with the conversion factor, okay?
How much yard is there in the foot?
1 yard is 3
Oh, there it is. I didn't see that.
Yeah.
I didn't see that.
All right, guys, please use this table to solve these questions. Can you see from here?
For 1 year. Yard for 1 yard. 1 clusters. 3 times 3. 60 times 3 is 1 year. So this is what sign.
Would you like me to do the first or second one? Which one, guys? First or second?
Can you do number 14?
14. Let's wait for them to go more. I'm going to do the first one, number 11. This is 63 yards. Now I want to change it into feet. So my answer has to be in feet. Okay? I know this is over 1. The conversion factor between yards and feet, for 1 yard, there are how many feet? 3. So where do I put the feet? Up or down? Good. Now, yards. One up, one down, cancel out. So we have 2 fractions. How do we multiply? We multiply across. What's 63 times 3? And what's my answer? Feet or yards?
189 feet.
Huh?
189.
Okay. How many of you got this right, guys? Good job. Good job. Now, do we need to do number 2? Let's do number 2 quickly for some of you. Our number, not 2, is 12. Okay. 168. We change the hours into what? What do you change the hours to? Days. Okay. So this is my conversion factor, hours and days. Do I put the hours up or down?
Down.
Down, because this one is up. Put it over 1 so you can see it. So 1 day, I have 24 hours. Okay? Now, hours. 1 up, 1 down. What happens? Cancel out. So I multiply across. 168 times 1 is 168. 1 times 24 is 24 days. And what's my answer?
7.
7, exactly 7 days?
Yeah.
Okay. Is this hard, guys, still, or you're feeling better about it? Feeling better? Now, I want you to go over problem 4. A student ran the 50-yard dash in 5.8 seconds. At what speed did the students run in miles per hour? We had this yesterday. Now, here, we're converting 50 yards per second in yards over seconds into miles per hour. So we need to change 2 units. The yards has to be changed into miles, and the seconds has to be changed into hours. So how many conversion factors do we need? If we're changing 2 units, we need how many conversion factors? 2. If we need to change 2 units, we need 2 conversion factors. So I'll show you how to do number 4. Okay? So he runs. This is problem 4. He runs 50 yards in 5.8 seconds. Okay? Now I want to change it into, keep in mind, my answer has to be in miles over hours. Okay? So the yard has to be changed into miles, and the seconds has to be changed into hours. So I need to multiply by 2 conversion factors. So this is what I'm going to do. 1, 2. First, I'm going to change the yards. How many yards in a mile? Do we have it here? It's, I think, 1,760, something like this. Is this 160? All right. 1 mile is 1,760. Do we have it here? I need to double check. Can you double check with the? All right, I'm gonna double check. Okay, yes, it's 1,760. Okay, now I'm gonna change these yards. Where do I put the yards? Up or down? What do you think?
Down.
Down. Good. So I'm gonna put 1,760 yards down. Up. Now, yard and yard go away. I need also to change the seconds into what? Hours. I know 1 hour is how many seconds?
3,000, 36,000.
3,600 seconds, okay? Now, this is my conversion factor. So when I multiply it, where do I put the seconds? If my seconds were down, where do I put it on this? I put it up, 3,600 seconds, and I put 1 hour down. Now, the seconds went up, went down, they cancel out, okay? Now, I have 3 fractions multiplied. How do I multiply? I go across. 50 times 1 times 3,600. We do it with the calculator. And the answer, the top is in miles. Okay? Over 5.8 times 1,760. And that's hours. Multiply tops, multiply bottom, then divide. Top divide by bottom. Okay? See how I could change 2 units at once? When I multiply them by 2 conversion factors. Each one takes care of 1 unit. Okay? Any question, guys? You feel more